In this session, we are going to walk through a PBL activity. You're going to perform an activity which will somehow demonstrate electricity and magnetism, in particular electromagnetic induction in the classroom. So you will be evaluated in your performance based on the following criteria. Teamwork, 20%. Your working device is 40%. And science concepts, 40%. Okay, ang gagawin natin yan. Ano ang ating problem scenario? Okay. Let's say that you are an engineer working at the North Wind Power Development Corporation in Bangi Bay, Ilocos Norte. Your former high school teacher in Manila has just invited you to speak in her physics class to inspire her students to pursue STEM-related careers. Okay? You want to make a good impression. So, instead of just telling the students or the kids what to do, you decided to do a simple demonstration of how wind energy is converted into electrical energy. So you scoured for some scraps in your workshop and you found a box that will help you with your problem. I call this the magic box. Ayan. So bawat isang group, meron kayong box niyan maya-maya. So, your best friends volunteered to help you out with the preparations and the polishing of your presentation. Use the engineering process design in constructing your device. So what's the problem? Your role is that you are an electrical engineer and your team members are your best friend. And then what you're going to do is to prepare for your presentation, a show and tell in the classroom of your former physics teacher. Okay, so using only the materials inside the box, which I am going to give to you, construct a device that will produce the most number of lighted bulbs. Okay, I made it less complex because we don't have much time. You have to do this in 15 minutes only. Okay, I prepared actually 5 groups, but because you're only 3, ayan, ito yung black yung inuna ko para hindi nyo makita ko nung nasa loob. Surprise! Ayan na. Okay. Alright, this will be mine. So, ito, tsaka to. Yan. So, may I ask for a representative from each group? Pili po kayo ng isang box. Okay. Ayan, so sa loob po ng box na yan, lahat ng kailangan nyo para magawa yung inyong device to demonstrate electromagnetic induction is there. Okay? So you will only do this in 15 minutes. You don't have to use all of the materials, but you cannot add anything on the materials. Okay? So yan lang yung gagamitin nyo. Pwede hindi gamitin lahat, pwede rin gamitin lahat, basta walang idadagdag. Okay? Ready? Ready na? Okay na tayo? Okay, so 15 minutes starts. It's just 3 minutes per group. Just tell us how many bulbs, so paano nyo siya ginawa, what did you learn from the activity, etc. And how did you come up with the working device? Okay. Alright, thank you very much, Greenery team. So palakpakan po natin ating mga sarili. You did a great job. Nasagutan nyo po yung challenge. Let's reflect on your results. What do you think should be done to improve your device? Paano natin mapapadami pa yung pwede niyang i-light? So, anong mga observations ang nakita niyo po? Okay. You just went through the loop of solving the problem. Ganun eh. Okay, so let's talk about your experience this time. Not on the device, but on your experience. Okay? What challenges did you meet when you tried to solve the problem? Okay, so it actually required you to recall your previous knowledge about electromagnetic induction, right? So that's about how you can produce electricity out of changing magnetic flux. But before you can do that, you have also to recall about what's a breadboard. Tama? Okay, paano nakalinya yung breadboard? Paano siya naka-wire, for instance? Paano din dapat ilalagay ang LED? Because once, if you might have noticed, once you will switch the polarity of the LED, hindi na po siya iilaw. Okay? And then probably this group discovered na may polarity din yung inyong DC motor. Tama? Polarity ng DC motor, pag tinurn mo siya on one side, hindi ilaw. Pag tinurn mo siya on the other side, iilaw yung LED. Okay, so there is a way to turn the DC motor as well. And then you assemble a team. You already have a team. And then you identify your roles. One of you is the engineer, and the other one is the friend. Okay, and then you plan and provide a solution to the problem, okay, which is what you also did a while ago, although we did not have the documentation for that one. And then we try out the device. You have tried out the device several times before you presented it to the class. And then finally, we evaluate the results. Okay, and then try to look into how we can improve on the material. Okay, so if you would notice, kapag yung ginawa ninyo kanina, kapag hindi ka pa masyadong familiar doon sa material or sa problem, you actually automatically pinpoint areas, 'di ba, na gusto mong malaman. Paano nga ba yung LED, right? Paano nga ba siya kinu-connect? Yung dynamo, paano nga, sabi nga nito kanina, nakalimutan niyang may polarity nga pala yung DC motor, na kapag inikot mo sa kabilang side, inikot mo sa kabila, magkaiba yung kanyang polarity. Pwedeng negative yung other side na red, pwedeng positive yung kabilang side, etc., etc. Okay, so you just went through this loop. Okay, so kung nahirapan kayo dun sa researching part, that is also probably times 5. Ang mafe-feel ng mga estudyante mo when you give them something na hindi pa sila masyadong familiar. Okay, and those are some things that we need to consider. Now, when I presented the scenario a while ago as well, nagbigay ako dun ng hint, use the engineering design process. Okay, anybody here who knows the engineering design process? Or familiar with it? Okay, familiar na kayong lahat nun. Okay, ayaw nyo lang sumagot. Ganun eh. Okay, ano ba yung mga engineering and scientific practices? Okay, this is what we do every day, right? As science teachers. Okay, we ask questions, we define problems, we develop and use models, we plan and carry out investigations, we analyze and interpret data, we use mathematics and computational thinking, and then we conduct explanations if that's for the science part, or we design solutions for the engineering part. Or we engage in an argument from the evidence. Okay, so nakita natin yung result, pag kulang pa, well, paano kaya natin siya mapapaganda? Then we obtain, evaluate, and communicate information. So if you're going to take a look at the two, they're very similar. Yun lang, ang focus ay magkaiba. Sa engineering process, we do well on the problem. How to solve the problem. And then we give different solutions and we choose from those different solutions the best one. Okay, and then we just iterate the process over and over, and then we communicate the results. Okay, communicate natin yung results doon. When we had the chance to show our working devices. Okay, now, we can extend the reflections on our activities based on one, kanina ay nagbibigay lang ako sa inyo ng mga guide questions. This time, we will extend the reflections on the activity that we have just conducted using the bonus 6 thinking hats. Sino na ang gumamit nito? Ayan. Alright. So, blue hat is process, red hat is feelings, white hat is facts, green hat is creativity, yellow hat benefits, black hat is cautious, and then we call this the parallel thinking process. Okay, so when we do reflective activities, pwede na tayong gumamit ng mga iba-ibang guide questions if you like. Sa journal naman yon. Or you can give them the 6 thinking hats. Paano ba natin siya ginagamit? For evaluation, we can use these different hats to answer some specific problems. So mapofocus yung attention ng estudyante on one part of the activity only. So let's say, white hat. So what do we know? What do we need to know? And how did we get this information? So pwede siyang mag-focus doon during the reflection time. Judging, ano yung mga difficulties and weaknesses? Creativity, that's green. Ano yung mga new ideas na na-learn niya? New opportunities at paano i-improve. And then, the red hat is on gut feelings. When you received the materials, okay, you have a gut feeling of what to do. So ano yung feeling na yon? How do you describe that feeling? Then you have the yellow hat, being optimistic. So what are the strengths and opportunities that you find for the activity? And finally, the blue hat, you think about thinking, what did you learn and what's next for you after this particular activity? So we can use these prompts at the end of the activities so that we can bridge kung ano man yung ginagawa ng estudyante natin ng mga activities today to the next different topics. Okay? And we can also use this for planning as well. Okay? Like the process, for instance. So you think about thinking, how do you organize your thinking, and what is your plan of action? You have white hat as well. So on information and data, the same thing with red hat, the feelings, and then black hat for caution, yellow hat for benefits, green hat for creativity. All right. Would you like to try the 6 thinking hats? For reflection of the activity. So evaluate natin yung activity. All right, so these are just one of the many ways by which you can reflect on the activity, both in the activity and on the product of your students. Remember the different key elements in the PBL? We have the driving question. Ano pa yung sumunod? There is sustained inquiry. Okay, there are 7, right? And then we have authenticity, that's also one. Then, student's voice and choice, okay, which he didn't have. Kasi, due to time constraints. All right, what else? Reflection. Okay, reflection, we've done that in a bit. And then what else? Critique and revision. Okay, so dinaanan din natin yan ng konti. And then, lastly, public product display, which is hindi rin natin nagawa. Okay? We just went through that loop. Ngayon, may kulang doon. Ano ang kulang? Okay. The specific criteria for that, I didn't give you. Okay? Hindi ako nagbigay. So, pwede natin yung idagdag as an improvement in the course of action. What else? Monitoring logs as well, para dun sa student natin kapag gagawin nila ito sa, let's say, pag ginawa mo siyang mas komplikado, mahaba yung time na ibibigay mo sa kanila para mas ma-monitor mo yung kanilang progress. Okay? Okay, safety and precautions as well. Okay, kasi they are going to play with electric circuits for that matter. Okay? Now, saan kayang lesson or saang stage sa K-12 standards natin ito pwedeng i-apply? At ano kaya yung ginawa nyo, yung kakagawa nyo lang na activity, ano kaya ang mga learning standards ang pwede nyo i-hit? Okay, so we can revisit our K-12 standards for that one, okay? Para mahanapan natin siya ng, baligtad tayo ng ginawa, no? Activity muna, tapos hanap tayo ng standard. Here are the standards. So, in fact, pag titingnan natin yung key stage standards ng 7 to 10, we have there, at the end of grade 10, learners should have developed scientific, technological, and environmental literacy. Okay, which that includes understanding of science concepts and applying science inquiry skills. So the activity alone, if they will go through stages of inquiry, that can hit the key stage standard. Okay, and then the learning competency, okay, grade 9 is one. Explain how electrical energy is generated, transmitted, and distributed. Okay, in fact, pwede mo siyang and grade 10 as well, dalawa siya. Demonstrate the generation of electricity by movement of a magnet through a coil, or explain the operation of a simple electric motor and generator. Okay, so pwede natin siyang ipasok. Yung sa grade 8, meron na siya doong series parallel. Okay, series parallel. But because we are using the dynamo, mas appropriate siya dito sa S9, 10 as well. Okay, in fact, pwede niyo i-cross yung competencies na yun. Okay, from grade 8, 9, and 10. But we don't recommend that. Right? Because the grade 8 students might not be ready. Well, it depends. It depends on the skill and the abilities of your students. So, I use this activity as well in one of my classes in Zamboanga del Norte, yung mga first ko ng mga high school students. And the first problem that I met there was that they don't believe me. My students did not believe me. You know why? Because they went through an electrician. Okay, nagpunta sila sa electrician. Okay, sabi ko sa kanila, sige, mag-demo tayo ng, gumawa kayo ng model ng, binigyan ko na sa kung ano gagawin. Maggawa tayo ng model ng power plant. Okay, so, di ba, ganito lang, sa drawing, ganito lang yung kasimple. Sigawin natin sa totoong buhay. So, ang sabi ko, pwede ba natin baligtarin yung electric fan? Ganyan. Tapos, edi nagtanong sila ngayon, gamit na lang tayo ng dynamo. Why don't you use a dynamo? Sabi ko gano'n. DC motor. So, ang ginawa nila, give them about a week to do that. So, ang ginawa nila, nagtanong sa electrician. Ang problema, pinagtawanan sila ng electrician. Sabi ng electrician, paano yan iilaw? Wala kayong battery. Ganun eh. So, they went back to my class and they told me, hindi naman yan gagana kasi wala ngang battery. Ganun eh. Kasi walang battery. So, sabi ko, saan yung battery ng power plant? Ganun eh. Okay. So, that's one of the problem. Okay? That's one of the problems. They meet someone they thought was an expert, and then all of a sudden, they don't believe you because you are just, teacher. Ganun eh. You are just teacher. Okay? But anyway, may gumawa din yung electric fan. Binaligtad niya. Wala ding nangyari. Okay, ano yung problema doon? Kasi walang magnet yun. Ganun eh. Walang magnet yun. Pag babaligtarin mo yun, kahit gaano pa siya kabilis, hindi yun magpuproduce ng electricity. So we learned that along the way as well. Okay, so masaya na medyo marami ding bumps. Okay, it's not a walk in the park after all, doing activities like this one. Okay, so that's one of the learning competencies there. Okay, meron bang pressing issue or problem in the community that you would like to solve? We can start from there. And do you think students will be able to come up with a solution to that issue or to that problem?